All right, let's get started. Okay, so tonight's the last night of material, okay? Tonight, we're gonna cover set and drift. Okay, we're gonna cover time ticks. Okay? I'm sorry I was speaking while you guys were interrupting. Anyway, so we're gonna do set and drift. We're gonna do time ticks. Okay, we got some miscellaneous TNAV stuff, and that's gonna be like compass error by ranges. Okay, and some other weird and something else, and you'll see that involves the maneuvering board. Okay, and then we have slip and fuel efficiency. Okay, so it's 4 different topics. All right, and we're just gonna kind of, but we're gonna go through all 4 of them. Okay, they're the easiest ones, and they're just gonna be all mushed up into one thing. This stuff here, you're gonna do a test on that next Thursday. Okay, test next Thursday on this stuff. Next Tuesday, okay, Tuesday's test. That's doubling the angle on the bow, special case. That's tides, currents. Okay, and currents, there was a bunch of different currents. Okay, 1, 2, 3, 4. Okay, so download the practice test, and you'll see what that's going to look like. Okay, very good. So let's just get into it because it's going to take us a little while. All right, so set and drift. Okay, so these current, you got this current triangle. All right, it's made of 3 legs. Okay, turns out that 2 of those legs are vectors and 1 of them is a resultant. All right, so you got current, DR, and made good. All right, so here's let's say this is my DR line. Okay, all right, course and expected distance. That's a vector. Okay, that's a vector. And then, like, maybe you got some kind of current. Okay, that's got a direction and magnitude. You steer in the boat, a speed, RPM, a course, that's a vector. The current pushing like that, that's a vector. The resultant is what you make good. Okay? Anything make good is the resultant. It comes from the combination of this and this, 2 vectors. Okay, tip to tail, and then the resultant, the made good, is what you get. Okay? Each one of these things has, Each one of these things has 2 components. Okay? You've got direction and magnitude. Okay? So you've got C, D, M. The direction of C is called set. The magnitude of C is called drift. Okay? The direction of the current is called set. The magnitude of the current is called drift. For the DR, the direction is course steered. Okay, it's whatever. Course steered. And the magnitude is RPM. Okay, or speed intended. Okay. What's the direction of the magnet of the made good? Course made good. What's the magnitude of the made good? Speed made good. Okay. It turns out for these current problems, you're going to be given 4 of these, and you're going to have to extract the other 2. Okay? You're going to be given 4, and you'll have to extract the other 2. One of the ways to extract it is really easy. If you're given this and you're given this, if you're given this and this is really easy to extract. If you're given some of this and some of this, and some of this, then you got to extract these 2. That's a little bit of a pain in the butt, but we're going to do it. Okay? So, okay, great. So just a little review, okay? Because some of these words can get a little bit, when you're reading the problem, if they say you are steering, that's going to be on the DR line. Okay? If they say your course is, that's the DR line. Okay? If they say your RPMs, okay, or engine turns, that's the speed of the DR line. If they say you wish to make good, anytime you see make good, you wish to make good, you want to make good. Okay, that's the made good line. Okay, and obviously anything about the set and drift, that's the current line. Okay, all right. It turns out that in your book on page 412, they talk about adding vectors. Oh, let me hide some of this stuff here. Okay, they talk about how to add that stuff up, whatever. Okay, so right now this is where we're at. Okay, that is on more or less on the board, and you're going to be given 4 of those variables. You got to extract the other 2. Okay, so let's do a problem. I'm going to do it up on the board, up on the PowerPoint. You wish to make a course of 035 true while turning 12 knots. Set is 340 and drift is 2 knots. What course should you steer? What speed will you make good? Okay. All right. So my suggestion for this problem is going to be, to think about that table. Okay. So let's do this table here. Direction, mag, C, D, M. Okay, let's populate the table. You wish to make a course of 035. Where are you going to put that? It's got to be in the direction column. It's either here, here, or here. You wish to make 035. Well, that's the direction of the current. Well, that's the direction you're going to steer. You wish, you want to do something. That's made good. Okay, right off the bat. Okay, you got to be able to recognize that. It's tricky stuff. That's why we're doing this. Okay, if you want to make something, that's the thing you want to make. That's what you're going to make good. Okay, cool. All right, so that's where that goes. Where is the 12 knots going to go? Okay, 12 knots is going to go here. That's the DR. Cool. All right. A set is 340. Where's 340 going to go? Here. Well, okay. I got 2 choices. Which one? 340 and 2 knots. Okay. Okay. So, what course should you steer? That's this. Course to steer. I don't know. Let's figure it out. Okay. Speed made good. Speed made good. I don't know. Let's figure it out. Okay. I'll just tell you something. If you see this pattern, this is the one where you have to swing your dividers. This is the one where you have to swing your dividers. If you use this table and the things you're looking for are not on the same line, you got to swing your dividers. Okay? All right, so let's do it. You ready? Let's get into it. All right, so here we go. I'm going to do it on the PowerPoint. I'm going to do it on the board too. This way I can't get too far ahead of you, okay? First thing I'm going to do is I'm going to plot the course that I want to do. Okay, so that is like 0, 3, 5. Okay? That's what I want to make good. Okay? So I'm going to plot that. There we go. Okay? And basically that table is on the PowerPoint here too if you want to go back and download it. Cool. All right. What's the next thing I know? I know everything there is to know about the current, right? So let's plot the current. How should we plot the current? Okay. 340. Okay, so what are we going to use for miles on this thing? I mean, I got 12 here. So, you know, I can't be like making like this 2 miles. Okay, so I'm gonna. It turns out that this is let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But look, there's 11, there's 12. I can plot 12 on the scale of this thing. I'm gonna make each of these things 1 mile. So boom, there's the current. 340, 2 miles. Yes. You could, but I want to make this thing, you could. But the bigger it is, if you make a little, the less impact that has. But absolutely, you could do 2s if you wanted, okay? So you could say 2, 4, 6, 8, 10, 12, and that would probably be fine, okay? All right, cool. All right, so now, all right, I have plotted this, I have plotted this, and I have plotted this. What's the only other bit of information that I know now? There's only one more bit of information that I know. Well, I plotted that. And I just plotted this. Okay, I know this, I know this, and I know this. I plotted all those. I'm looking for this and this. There's only one piece of information I haven't used. 12 knots. Well, what the hell? What am I going to do with that? I don't know where to put it. We only have one more piece of data to do something with. So we're going to do something with it. I'm going to measure 12, and then I'm going to, do I have a freaking triangle here? What is it? It's called the current what? I ain't got no freaking triangle. I got to make a triangle. There's only one way to make a freaking triangle in this diagram. Okay, really? There's only really one way to make a triangle. So how are we going to do that? Say that again, Ian. Okay. Okay. At the end of your course line, or your current line. And swing that shit? Yeah. Oh yeah, baby. Swing that. Okay, there you go. Cool. That's great. And I bet you that right now, at this very moment, just about everybody can do that in this room. Okay? Maybe everybody can do that. And I'll bet you at the next step, half of you will get the next question right. Half of you will get maybe this right and maybe this right, but the other half won't. Okay? So here is Terrence's suggestion. What line is this? C. What line is this? M. What line is this? D. Label your freaking lines. Label your lines. Okay? Label your lines. Now, it's a good look, all scrunched up like that. You know? Yeah, okay, great. Now, I want this. What line is that going to be on? D. Okay, so that's this line. So how am I going to pull that number off? Yeah. So that's the course I should steer right about there. Okay? If you don't label these things, you might start pulling numbers off the wrong line. Okay? So I highly suggest you label your lines, and then you do an analysis. I'm looking for something on the D line, the course. That's the D line. Don't confuse it with this line. Don't confuse it with that line. It's this line. If you don't have these labels on, you might just go ahead and grab it off of here. Okay? So cool. So there's my dividers. You like that? Huh? You like that? Nice, huh? And I move them over there. Now it gets kind of crappy now, but anyway, yeah, boom, there it is. Cool. Now I get my triangle. Put my triangle against that puppy. I slide it down here, and my course line ends up being right there. Okay, great. Great. So that is going to be, oh, I didn't finish this, but let's see. What should that course actually be? That course should actually be, when I bring it down here, it should be about 044. Looks like 043. Okay, yeah, Chuck.
So if you are doing that total mile scale, it's about 40 of the speed.
We haven't finished that part yet. Okay. So, all right. So here we are. Okay. Here you go. All right. So I just, I should finish this up a little bit. This is not quite complete. The animation should now take this line, bring it down here and go like that. So the course to steer should be about 0.43. Okay. Okay. So this should be about 0.43. Okay. Great. All right. Now, the question becomes, let's put this back up here and we'll use our dividers. Okay, now that is definitely off the scale. Okay, it's definitely off the scale. All right, so let me just do a little, so what can I do here? You could, but it's 10 miles from here to there. How far is it from here to there? 20. Well, shit. Take your dividers and go from there to there and just drop that little bastard up there to 0. Once you pass there, there's 10. There's 11, 12, 13. Just keep adding them up until you get the answer. Looks to me, I don't want to disturb this. Actually, you guys are worth it. You guys are worth it. So that's the distance. Okay. And if I took this, oh God, you're making me kill my freaking PowerPoint here. Chuck, I hope you see the love. I hope you see the love. And I go like this. Then I go like this. I put it right there. And I got to rotate a little bit more. But anyway, so that's 10, 11, 12, 13.2 miles. So that's 13.2 miles in the time frame of the triangle. Okay? So speed made good, okay, equals distance over time. So 13.2 miles in 1 hour, what would my speed made good be? 13.2 knots. But what if it was 13.2 miles in 30 minutes? It'd be 26.4 knots. Okay, so you might have to massage it. If you have an hour triangle, then it's easy. If you have a half-hour triangle, you got to double it. If you got a quarter-hour triangle, you got to multiply it by 4. Okay? So make the triangle, hopefully you'll make the triangle something that's easy for you, but depending on what the problem gives you. Okay? All right, let me just undo what I just did there. Okay, great. All right, cool. All right, so, you're going to have to futz around with that a little bit perhaps to remember it, okay? All right, cool, done. That was that one. Okay, now we're going to do one more, okay? This one is everything we just did, but it also has leeway. It also has leeway, okay? So let's just review that, and then we'll go on to the next topic. You're underway. You're underway, and you intend to make a course of 040. Okay, so I intend to make 040. What's that? It's a course, so it's a direction. Is it C, D, or M? I intend. Well, C is current. D is what you're going to steer. I intend. I wish. It's made good. See, this is where they get you. Okay? You have to be able to decode what's what. Intend, you want. That's what the made good is going to be. Okay? So you intend to make a course of 040. That's intent. Okay? So this is like M here, 040. I intend 040. You experience a current with a set and drift of 190. Okay, so made good. So I'm going to put 040 here. Okay, where am I going to put the 190? The current is 190, and the speed is 1.4. Okay, great. So I can go over here, and I can go 190, 1.4. That's current. Okay, I'm just ballparking it. It's going to show up nicely up there. And there's a northwest wind. causing 3 degrees of leeway. There's a northwest wind causing 3 degrees of leeway. It's pushing me. What's that going to do to my, if I was making 040 and now I've got 3 degrees of leeway, what's that going to do? It's going to make me go to 043, isn't it? So what am I going to do to compensate for that? Okay, so what that becomes is now you want to go 037 now. Okay, so this actually becomes 037. That's what you're going to plot here. You're not going to plot the 040. You can start with the 040, but apply the leeway to it, and then that's going to be your made good. This one, you might have started off by drawing it, but as soon as you realize it's leeway, compensate for the leeway, and then make that your M. Okay? All right? Okay. So now we're going to plot that thing. Yep.
Will you ever have like a leeway or wind direction that's going, like let's say that was northeasterly wind? How would you do it then?
If it was exactly an opposite, then what you do is that would start to affect your speed made good. Okay.
Will we
It would.
anything like that?
Well, if the wind was just like this, there would be no leeway effect. If the wind is on your bow, it's not going to affect. Okay, it'll affect your speed at the end. Okay. And so they're not going to ask you that question.
Okay.
Okay. Yeah. Let's leave it that way. They're not going to ask you that question. All right. So this is where we are now. Oh, they told me my RPMs are 10. Where am I going to put that? Engine speed's 10. There you go. It goes right there. So this was 040 minus 3. Now this is 037. Okay. Cool. All right. Well, they want to know, what should I steer and what's my speed made good going to be again? Oh, boom, boom. Swing that shit. Swing dividers. Okay, you see that? It's swing dividers. The only other pattern is they give you this, and they ask you to calculate all this. You just do that by inspection. Okay? So, if they're, all right, that's what you hope for, but that's not what you're going to get. Okay? Cool. So, how am I going to do this now? There's 037. I plot that. I plotted the 037. Check. I plotted 190, 1.4. Check, check. What's the only thing I ever freaking plotted? That's the only thing I haven't plotted, 10. Well, what the hell am I going to do with that? I still don't have a freaking triangle. We'll close that shit. You're going to close it now, right? Yeah. All right, so I'm going to go like 10. I'm going to go like a this, and I'm going to go like a this. Okay? So, here we go. And that'll be like 10. Boom. That is D. Okay, don't forget the label. Okay? All right, then. All right, so using the colors of the lines, I don't know, can you see that this line is green, this line is black, and this line is red? Black, green, red. They're not labeled on that. Okay, I guess I got a little lazy, but they are labeled here. So Tom, I want to know the direction I should steer. What course should I steer? Which line are you going to pull it off? You can give it by color based on the PowerPoint. Oh, wait a second. I got some color. Yeah, check this out. We got some colors here. Oh, screw it. Okay, we do it off of here. Okay, there's a yellow line, there's a red line, there's the white line. I want to get the course to steer. What color line are you going to pull it off of? Yellow. Yellow. Yes. And you knew that because you labeled your freaking lines and you know you're looking for something on the old B line. So, how would you do that?
Take your dividers or your triangle.
Yeah.
In the middle.
Yeah, well, you take a triangle, you go like this, and then you bring it to the middle, and then you read it off right there.
Yeah.
Done. Okay, cool. All right. Ren, I want to know this one. Where am I going to get that off of? Oh, the red line. We're going to get that on the red line. How am I going to pull that off the red line? Right there. Boom. Measure that. Boom. Done. Okay? Cool. Set and drift done. All right. This little table is a very useful thing. Tips, yeah, whatever. Yeah, use a big scale, label CDM, make your box. Oh, you can also do this by law signs if you want, probably don't want to. Mr. Bonnell might want to, but anyway, okay. You know, remember that everything is fine and good until you get to the speed made good. And if you're not in an hour-long triangle, you're gonna have to multiply that speed. So if you got like let's say you got 2 miles from this, okay? Let's say Ren, you measured this and it was 6 miles. Okay? Well, actually, what is the time frame of, based on the problem, what is the time frame of this problem? I plotted the entire current, didn't I? That makes it an hour-long triangle. Okay? Because I plotted the entire current, it makes it an hour-long triangle. Yeah.
They give you one where you notice like, just said like they give you one where you notice like 1.4 knots over a half hour. That's still.
So 1.4 knots over a half hour, I would plot 2.8 miles if I wanted it to be an hour. All right, I'd plot that. All right, but anyway, so if this was over a half hour, it was 6 miles. I got to multiply that by 2. Okay, just keep that in mind. Okay, great. All right, that one's done. Okay, stop that share. All right, now we're going to share another one because you love it. Time ticks. Anybody on Zoom got a question? Hope you can hear me. Okay. Let's start from the very beginning. A very good place to start. Okay, time ticks. All right, now have any of you ever heard the time tick before? Okay, check this out. At the tone, the time will be. All right, there we go. So it turns out that we have very nice, accurate watches now, but you know, back in the day, 20, 30 years ago, not everybody had like a quartz watch. So this is you would tune into a station on the radio. You turn into a station on
0 hours, 29 minutes, 14 universal time.
Oh, that's the moment. Oh. Oh, it's because it's my own speaker. I'm zooming into myself. Okay. Anyway, I'm zooming into, anyway. Okay. So if you wanted to know really precisely what time it was, you would have to tune into that sound. There's radio, they still do, okay? At the tone, the time will be 2100 hours, 6 minutes, coordinated universal time. And at the moment that tone began, you knew it was exactly that time, okay? So let's just talk for a minute about all the little timepieces that were traditionally on boats and still are, okay? So what time is it? Remember, I want you to remember something, okay? That, until, I don't know, 20 years ago, all the clocks on the planet looked like this. There weren't too many digital clocks. They were all analog clocks, all right? So that's a little chronometer, all right? This is another, this is a pocket watch or a stopwatch. This might be a ship's chronometer protected inside a box. That's one as well, okay? And, but, they lost or gained time. They didn't keep time accurately. You had to wind them up and all this kind of shit. So you never really exactly knew exactly what time it was. You were always kind of in the ballpark. So how did you really know exactly what time it was? You tuned into the frickin' radio. So you had a radio room and you'd tune in. Now the radio room though was not in the bridge. Certainly it might, if you're lucky, it might be behind the bridge, but sometimes it was in a different part of the boat. Okay? So we know what time it is in the radio room, but I gotta look at I gotta look at the clock in the bridge. Okay? So your first clock in this whole experience in these problems, you're gonna be dealing with 3 clocks often. Okay? You're gonna be dealing with 3 clocks. Okay? 3 clocks for many of these problems. 1, the radio clock, which is sound only. There's no hands or nothing like that. Just boop, that's the time. Okay? Then 2, you're going to have what's called you're going to either have a stopwatch or a comparing watch. That's another second timepiece. Okay? And then 3rd, radio clock, sound in radio room. And then you're going to have the chronometer. That's on the bridge. The official clock's in the radio room. The clock you're going to do your CNAF off of is in the bridge. What do you think this one's for? It's for running from the frickin' radio room to the bridge. Okay? All right? So what's going to happen here is that when it goes, we're going to start our stopwatch if we're using a stopwatch. Or when it goes, we're going to see what time the comparing watch says. Okay? And then when I walk to the bridge, when I get to the bridge, if it was 1 minute, then it would be 1 minute after whatever they said it was. And if this was 18 seconds slow, but it's 1 minute later, then I know that I was 18 seconds. Anyway, we're going to do a problem for that. Okay, so anyway, here you go. That's the radio room on the left. The green one is the bridge. And there's the chronometer on the bridge. And you got to walk. Here's showing that here's the freaking radio room on this ship. And there's the bridge up there. It's a long distance. Okay, so you would have this little thing to help you get from here to there. Okay, great. All right, 1, 2, 3. Those are the 3 timepieces we're talking about in this little scenario. So the chronometer error, rating the chronometer. So the chronometer error is, how far off a chronometer is from UTC. The rating of the chronometer is is it getting faster today or slower today? It's not the error, it's how much has the error gotten worse or better? That's called rating the chronometer. You're gonna have to do that, okay? The time tick I just did and the comparing watch talked about. Okay, great. Here you go. Ready? We're gonna do this problem. Well, we're almost already done with this. You are taking a time tick using the 12 o'clock signal from Valparaiso. That means that on the little, it's at the tone, the time will be 1200 hours coordinated, okay, universal time, okay? So they'll tell you just before they beep what the time is gonna be. So in this case, in the recording, it would say at the tone, the time will be noon, 1200 universal. And by the way, it's GMT. You hear a series of 1 second dashes followed by a 9 second silent period, then a long 1.3 dash, okay? At the beginning of the dash, your comparing watch reads 12:08. So in this case, we're using a comparing watch. So you see all this stuff? You hear a series of 1 second dashes followed by 9 seconds. That's all bullshit, okay? That's all bullshit. Don't pay any attention to that. When it says at the beginning of some sound, that's when you started your stopwatch or you looked at your comparing watch. So I look at my comparing watch and it says 12:08. What's the real time? $1200. So what's going on with my comparing watch? It's 8 seconds fast. It's 8 seconds fast. Okay, now it's 18 seconds. I'm sorry. It's 12:00:18. All right. Okay. Yeah. I'm sorry. Okay. So what time is it GMT? 1200. What time is it by my comparing watch? 1218 seconds. So what's the comparing watch error? 18 fast. How long is it going to be like a minute from now? How fast is it going to be like a minute from now? 18 seconds fast. How fast is it going to be like probably half an hour from now? 18 seconds fast. Maybe, okay, so how long is it going to take me to walk to the bridge? 1 or 2 minutes, right? So here's what happens. I'm in the radio room. Oh, I look at my comparing watch. Oh, it's 18 seconds fast. Okay, I'm going to remember that. Because these are both set to Greenwich. On my ship, it might be 8 o'clock in the morning, okay? But these are all set to GMT. So I notice it's 18 seconds fast. Now I start to walk to the bridge. Hey, boss, how you doing this morning? Oh, that coffee's real good. And then, yeah. Hey, you missed that spot there. Anyway, Anyway, so there we go. Okay, anyway, go on like that. It turns out, when I get to the bridge, I look at the chronometer on the bridge. So this was clock 1. This is clock 2. Then I get to the bridge and I look at clock 3. That's the chronometer. What time does the chronometer say it is? It's 11:59. Okay, 35. Okay, that thing is definitely slow. Okay? What time does the comparing watch say it is? 12:01:23. Okay? So, how long did it take me to walk to the bridge? The comparing watch was 12:00:18. Now it's 12:01:23. How long did it take me to walk to the bridge? Comparing watch 12:01:23. Okay? And it was 12:00:18. Yeah, that's 1 minute and 5 seconds. Okay? 1 minute and 5 seconds. Okay? Oh, that's interesting. Well, let's do a little math here. All right. UTC 1200. Comparing watch was 12:18. It was 18 seconds fast. Okay? Cool. So how long to walk to the bridge? It's 1 minute and 5 seconds. Okay? Does that really matter that it's 1 minute and 5 seconds? No. Because no matter what time, when I get to the bridge and I look at the comparing watch, it's always going to be 18 seconds faster than GMT. So what am I going to do? If I want to know what time it is at GMT in the bridge, subtract 18 seconds from that. So here you go. You ready? What time does the comparing watch say when I get to the bridge and I look? All right, so here you go. When compared to the chronometer, the comparing watch reads 12:01:23. 12:01:23. What time is it really in GMT? It's 12:01:23 minus 18. So GMT is really 12:01:05, isn't it? Hell yeah. So, in fact, on the bridge, the time tick tone happened 1 minute and 5 seconds ago. I don't really care though. All I have to do now is, it's 12:01:05. What time does the chronometer say it is when I look at that? 11:59:35. So what is the error? It's 1 minute and 5 seconds and 25 seconds. It's 1 minute and 30 seconds slow. My chronometer on the bridge is 1 minute and 30 seconds slow. Okay? Chuck?
Take the difference between UTC and the time given for C.
Yes. Now look, here's the thing. We have these digital watches now. Maybe you guys are resetting your watch every day to your GPS or something like that. You didn't have that option back in the day. You didn't screw around with these chronometers. You wound them up at the beginning of the voyage and then you just let them go until it was time to wind them up again. You did not reset them. So day 1, it might be perfect. And then day 2, it might be 1 second slow. And then day 3, it might be 2 seconds slow. And then day 4, it might be 3 seconds slow. And then day 5, all right, and then as it was winding down, when it was wound up really tight, it would run fast. And then when the spring started to get looser, it would run slow. Okay? And so you actually, I mean, like, if you want to learn a little history, you should read Longitude because you'll find out how these things were done. Okay? But anyway, what it boils down to is that when you wind the thing up, you'd have to figure out how fast it's running, but over a number of days, you would figure out, okay, now it's still running fast, but it's running fast slower. Anyway, at some point day, it's like break even, and then it's going to run slow. And you had to know that stuff. So this is what we're going to do now. It's called rating the chronometer. I'll tell you something. That the watch that Cook took on his on the voyage that he took, because he went, he was going out to Tahiti to transit of Venus, all this kind of stuff. He took a watch on his trip to test Harrison's watch, okay, H5. That watch was in the British Observatory for something like a year, being compared to the star clock to rate it, so that when he went out there, he would be able to accurately predict if it was running fast or slow, depending on how many days it was since the last winding. And when he got back to freaking Europe, like 2 years later or something like that, they were able to calculate their anyway, it was amazing stuff. Let's not worry about that now, though. All right. On July 23rd, you take a time tick using the 0900 Cape Town. Okay, it's 9 o'clock GMT. You hear a repeating series of 59 dots followed by a dash. I don't care. That's a distractor. At the beginning of the 5th dash, okay, so that's when we start. The 5th dash, you start your stopwatch. Okay? All right. So at the beginning of the 5th dash, you start your stopwatch. The chronometer in the bridge reads 8 hours, 39 minutes, and 16 seconds at the time the stopwatch reads 1:42. What happened in that 1:42? You walk to the bridge, okay? So it's now, if you walk to the bridge, it took you 1 minute and 42 seconds. Your stopwatch says 1 minute and 42. What time is it GMT? 09:01:42. Okay, and that stopwatch is sweet. You just add it right in there, okay? The chronometer error at 09:22, so the chronometer error yesterday was 22 minutes, 24 seconds slow. What is the chronometer rate? So yesterday, when you checked your chronometer, it was 22 minutes and 24 seconds slow. That's almost half an hour, but you didn't screw with these things. You did not adjust them, okay? You did not adjust them. You just wound them up, okay? You rarely adjusted them. So yesterday it was 22 minutes and 24 seconds slow. What they're asking today is, they're not asking what's it's fast or slow today. They're asking, how is it different from yesterday? Okay, so let's take a look at this. It was 0900 UTC. Okay. We know that when I got to the bridge, it was 1:42, which means it's 09:142 UTC. Okay. When I compare the 09:142 UTC to my chronometer, what time does my chronometer say it is? 08:39:16. So, what is the error? I do a little bit of math, and it turns out that my error today is 22 minutes, 26 seconds. Today, my error is 22 minutes, 26 seconds. Okay, error. Yesterday. Was 22:24. Error. Today, what's the error today? 22:26. How much different is 22:24 to 22:26? 2 seconds. So now you gotta say it's gaining or losing. Okay? It's gaining or losing. Which one do you think it is? Do you think it's gaining or do you think it's losing? Okay, you think it's gaining. Okay, but that's not it. Okay? It's gaining relative to GMT or losing relative to GMT. Okay? So imagine that the camera, so here's what it boils down to. It's 2 seconds farther off, okay? It's 2 seconds farther off, which means it's 2 seconds further away from GMT, which means it's losing its time. It's getting worse, okay? However, if this was 22:20, it's 4 seconds closer to GMT. It's like heading back towards GMT, so it's gaining on GMT. Okay, so if the time is getting farther, so let's say this is GMT, okay, and we got a number line here, okay. The number line is plus time, and the number line is minus time. Yesterday we were here, 22. Today we're here, 24. We're getting farther from GMT. That's losing. Okay. If it was less than, it would be gaining because now I'm heading in the direction of GMT. What happens when I cross GMT and I'm gaining? What happens? How about here? Now I'm losing because now I'm going to the other side. Okay? All right, that was done.
So you'd be losing for this problem.
I'm losing. I'm losing on this problem. Okay? Slow today, slower yesterday, rate, getting more wrong, losing. Okay, as you get more wrong, you're losing. Okay. All right. That one's done. Okay. Now, this is some miscellaneous stuff. Okay? You're on a course at 251. I don't know, you guys, anyway. So this is we're going to skip this over because this is just like with the first worksheet we did. Okay. These things were like the first worksheet. Okay. You got to do those again. Okay. Because anyway, whatever. This is different. Okay. You're steering 110 at 20 knots. At 0900, a light is 7 miles bearing 090. At 0906, you alter course to leave the light 1 mile to port. What course should you steer? You can get this on the TNAV section, which is 10 questions, 1 wrong. Okay? So I think the way to do this is on the maneuvering board. I'm steering 110 at 20 knots. Okay? So what I'm going to do is I'm just going to plot a line 110. Okay? At 0900, a line is 7 miles. So what I'm going to do now is I'm going to plot, it's 09, at 0900, a light is 7 miles bearing 090. So I'm going to assume now that this right here is going to be 0900. So where is the light relative to that spot? It's 7 miles bearing 090. It's going to be right over here. So I just put a little dot on my piece of paper. Okay? At 0906, you alter course. Well, if this is 0900 here, where's 0906 going to be? Somewhere down here, right? What speed am I making? 20 knots. How many minutes have passed? 6 minutes. A lot of times these rules are set up with the 6-minute rule in mind. So I'm going 20 knots in 6 minutes. How far would I actually go? Take your decimal, move it 1 place. 2 miles. That means when I alter course, I'm going to be there. Okay? Now, how far do I want to be off this light when I do that? 1 mile. So I put a 1 mile ring around it with my dividers. Now, I mark that spot, and then I just draw a line that intersects that ring, tangent. So what should I steer? I should steer like 098, right? So I should steer 098, shouldn't I? No. I should steer, I got to bring it to the center, and I got to steer that. Okay, so that's that, done. Okay, that's that. We've covered 3 of the topics now. Okay. The last one is pitch. Okay, there's two little things here, okay? So there's all this and you did this in TNAV too. You got pitch, you got speed of advance, you got this engine speed stuff, okay? So on the test next week, we're going to give you a formula sheet. Let me just show you what that formula sheet looks like. Hold on a second, let me stop sharing here. Wait a second. Oh, wait a minute. Am I not going to be able to share that? Okay. What's going on here? Well, let me try one more time, and then we'll say screw it to the PowerPoint. Oh, it's not letting me advance. Okay, here we go. Okay, great. All right. Slip efficiency and fuel consumption. So it turns out that these problems that you could get are also, this fuel consumption thing could be on the TNAV module, which is 10 questions. You can only get one wrong. Okay? So you really want to know how to do these things for your Coast Guard exam. All right? So if you have Lapware, you can find them in navigation problems, terrestrial observations, fuel conservation, and anyway, okay? So this is the formula sheet we're going to give you on the test, okay? So the formulas that you're going to really be interested in, okay, for slip problems are the ones that are in red, okay? So you got engine speed, okay, which is pitch, well, RPM times pitch. What do we got there? RPM times pitch, okay, times 60, okay, over 60, 80, okay? All right, that's engine speed, okay? And, you know, percentage of slip, anyway, there's a couple other formulas there that you can use, okay? Observed speed over, okay, anyway, so we're gonna just do a couple problems. Those ones, the blue ones in blue, you're gonna use for speed of advance. All right, you're gonna have to memorize those for your Coast Guard exam. Tonight, we're actually gonna do one of these as well. You won't be tested on this on your Coast Guard exam, but you would on your Chief Mate Master, so we just threw it in gratuitously, okay? Okay, so here's some terms, okay? So there's an actual term and a theoretical term. Remember, advance is something you actually do. I advanced 100 miles today, okay? The theoretical term is pitch. My propeller turned, remember what pitch is? Okay, let's not even worry about that. Pitch, it's the distance the screw would advance through a solid in one revolution. It's given in feet, okay? So advance is the actual distance you would actually travel through a fluid medium, okay? So slip, to remind you, is the difference between pitch and advance, okay? Okay, so slip is pitch minus advance. An expression of loss, okay? So think about it like this. If you're tied up to the dock, and you engage the propeller and you start spinning the propeller, you're not going anywhere. You got 100% slip because you're not moving, okay? All right, if the propeller is making turns for you to make 10 knots, but you're making 9.8, you have loss, okay? That's slip. If the propeller is making turns to propel you at 10 knots, but you're making 10.2, you gain something somewhere. You got wind or current behind you. Okay, that's slip, but that's negative slip, okay? Anyway, so efficiency is 100% minus slip. Let's just do a problem, okay? So here you go. I'm gonna do this problem up on the board. So you're gonna have a formula sheet and you're gonna have a question. You gotta sort of just match stuff up. So here you go. Example 1. Okay, your pitch equals 23.4 feet. Your RPM is 87 revolutions per minute. Okay? Your observed distance in one day is 538 miles. What's the slip? Okay, what's your slip? Okay. So, looking at your formula sheet here, we're trying to figure out our slip. So I look for a formula that's about slip. And it looks to me like there's a formula right here, percentage of slip. The formula is engine speed minus observed speed over engine speed times 100. Okay, that's basically the percent. That puts it into a percent, okay? Great. So, engine speed. I look on the formula. Where's the formula for engine speed? Oh, here it is right here. Okay? All right? So, so I got to calculate my engine speed now. I need to calculate my engine speed, and I got to calculate my observed speed. Okay, so engine speed, ready? Is RPM times 60 times pitch. That's all over 60, 80. So RPM, 87. 60, that takes it revolutions per minute. That's 60 seconds in a minute. That puts it into hours. Okay, because speed is hours, nautical miles per hour. So that is a unit. That's a conversion factor. Okay, for that. And then the pitch is 23.4, all over 60, 80. So my engine speed is, based on that, would be 20.09 knots. Okay? So up here, okay, this is 20.09 minus something over 20.09. Okay, and I got to multiply, do a little multiplying over here too. Great. Now I got to do observed speed. Well, what's my observed speed? My observed speed is 538 miles in 24 hours. Okay? It's 538 miles in 24 hours. So I divide 538 miles, 24 hours, and that gives me 22.4 miles per hour. Great. 22.4. Okay? Times 100. Plug and chug, 11.5. Okay? And 20 minus 22 is negative, so it's negative. Okay? Done. All right. Look at the problem. Look at the formula sheet. Okay. So, there's other ones too. Let's go back to this. Okay. Do one more. Your slip is negative 11.5. Okay. Let's do one more like that. I got two more. I got a problem. Let's do the. I'll tell you what I'm gonna do. I'm gonna show you the consumption problem, and then I'll do a couple more of these slips for anybody that wants to stick around. If you want to leave now, go right ahead. Okay. But okay, here's another kind of problem that uses these formulas down here. Okay. So you've been consuming 215 barrels, okay, a day, okay, at 18 knots. Okay, so you've been running at 18 knots and you've been doing 215 barrels a day. Question is, what would your consumption be if you reduce speed 14 knots? Okay? I mean, you're running harder, you're gonna conserve more. If you reduce speed, you should use less barrels per day. Well, down at the bottom there's the formulas for that. Okay? So you see that one, new consumption? This one right here. Okay? New consumption divided by old consumption equals new speed cubed divided by old speed cubed. It's not bad. It's just a plug and chug. This is what I'm looking for, my new consumption. Okay? So, my new consumption divided by, what was my consumption yesterday? 215. Equals, what was my speed yesterday? What am I going to do to that? Cubed. What's the speed I'm going to be doing now? Cubed. Okay? So what do I have to do? 18 cubed divided by 14 cubed times 215. Okay, so I got to get the 215 out of there by multiplying both sides by 215. I end up with 215 over here. Those cancel out. And 18 cubed divided by 14 cubed times 215 is 101.2 barrels. Okay? That one is really easy. You won't get that on your coast, okay, but you until later on. All right? So that concludes tonight. What I'm going to do now, though, is anybody wants to stick around. If you want to stick around, I'm going to do this problem. I'll do because these can be a little bit tricky. I'll do this one. Yeah. Yeah. Yeah.
You said you're gonna give us an equation sheet?
Yeah, I'm going to give you the one I showed you in the beginning of the PowerPoint. It's actually on Canvas.
Is this one?
Yeah, it's the same. It's the same. It's exactly the same formula.
There's one, so like the one we just did, this has old consumption over new, not new over.
Well, okay, so if it had old consumption, then it had old speed.
Yeah,
Well,
so, okay, so it doesn't matter.
a matter of fact, you could go new consumption over old speed, old consumption over new speed. I mean, you can rearrange this thing 4 different ways. See it? Anybody want to stick around? You good. I mean, I'm not going to be offended. Well, yeah, but it's slightly, yeah, they're all plug and chug. But you got to manipulate because you got 86,178. What are you going to do with that? Multiply by what? Well, I mean, you can actually see, well, you can see that, well, yeah, well, all right, so. Okay. Let's see you do the problem now. Okay, Corey, you can't do it now because you can't see the freaking problem. All right. But anyway, so you can, these are all the kinds of problems you can have. The key is posted. You can just look at them. I'm happy to do the problem up on the board. Okay. Or, you know, okay.